There you go. All right, so law of cosines. So we're going to let triangle ABC be any triangle. So again, we can use law of cosines with any triangle just like we use law of sines with any triangle. So it doesn't have to be a right triangle. Okay, so this triangle with A, B, and C representing the measures of the sides opposite the angles with measures A, B, and C respectively. Then the following equations are true. So this is your law of cosines here. Now all of these equations are basically the same. Okay, so if I look at this first one, I have a lowercase a, and then my capital A is the one attached to the cosine. So capital A is right here. That's your angle. It does have to be an angle next to cosine. Okay, then your lowercase a over here is its opposite side. So we're still finding that angle and its opposite side. So whatever angle you use, its opposite side is on the left-hand side of that equal sign. Okay, so I would have a squared is equal to b squared plus c squared. So those are your other two sides of that triangle. Minus 2 times b times c, and then cosine of angle A, which again is across from that side that we squared first. Okay, this one's exactly the same. It's just going from angle B. So if I go from angle B, its opposite side is lowercase b, and that's why it's on that left-hand side of that equal sign. Okay, and then A and C are your other two sides. Okay, we square those, add them together, subtract 2 times A and C, and then cosine of angle B, which was across from that side of lowercase b. Okay, same thing with C then as well. So the formula for each of these, again, is the same. The only thing that's different is that your opposite side and your angle here. You have to choose the correct angle, and then its opposite side has to go on the left-hand side of that equal sign. Okay, that's the only thing that's different about each of these. So you use the law of cosines if you know the measures of two sides of a triangle, or if you know two sides and the included angle. Okay, included angle means the angle between the two sides that you know. So if I knew the measure of C and the measure of B, your included angle would be A. Okay, if I knew the measure of C and A, your included angle would be B. So it's that angle between the two measures that you know. That's what included means. Now you do need to remember to follow the order of operations when you're simplifying this. Okay, so you have to multiply or divide before you add and subtract. Okay, multiply and divide before you add and subtract. So with this one, we do have to be kind of careful. Now, just like yesterday, we do have some examples, and we're going to solve for a variable. So, example 1, using the law of cosines, I always locate the angle given. Okay, locate your angle given. So that would be 28 degrees here. That's angle C. Okay, after I locate the angle I'm given, I need to find its opposite side. Okay, so the side opposite that angle would be X. So in my formula, if I look back up at the top, your opposite side is the one on the left-hand side of your equal sign. So that X value is the one I'm going to square. Okay, so here I would have X squared is equal to, now your other two sides, it doesn't matter the order of the two. Okay, so the order doesn't matter for those two sides. So we do need to take both of those and square them and add them together. Okay, so those are your other two sides. Subtract 2 times, again, those other two sides. So 9 and 11 again. Okay, 9 and 11. And then that's multiplied by cosine of your angle, which is 28. Yeah. So again, I went from my angle of 28 degrees. I had to find that opposite side. So that opposite side there is the one on the left-hand side of your equal sign. Okay, then the other two sides, doesn't matter your order within the rest of this here. Okay, so 9 and 11 were my other two sides. So then I'm just going to simplify a little bit here. So I have x squared is equal to 9 squared is 81 plus 11 squared is 121. Okay, then I can multiply all three of these together. So 2 times 9 times 11. That's 198. Okay, that's still multiplied into cosine of 28. Now what I can do next is add these two numbers together. I cannot subtract the 198 from those numbers. Okay, so I can add 81 and 121 to get 202. And then that's minus 198 times the cosine of 28. Since these are multiplied together, you cannot subtract these two numbers. Okay, that's why order of operations is important here. Do not subtract those two numbers. Do not do it. Okay, from here I can't do a whole lot, but I already kind of have x by itself, right? So to get this as just x, I would want to take the square root of both sides. Okay, so I have x is equal to the square root of 202 minus 198 cosine of 28. And that's what you're going to need to enter into your calculator. Okay, so square root 202 minus 198 cosine of 28. Entered into your calculator. Yes, you can do the square root of that whole thing right away if you want to. You don't have to simplify. And you should get 5.2. Okay, so x should be 5.2. Yeah. Yes. Yes. I have those ones, and I have law of sines on your test as well. No. Other questions on example 1? All right, then we're going to look at example 2. This one's a little bit different. Okay, so I'm still solving for x, but this time x is the angle. Okay, so that's the angle that I want to go from because that's the angle given. So this is the angle I want to go from. I need to find its opposite side. Okay, so the side across from that angle is 1.9. Okay, that side across from that angle is what goes on the left-hand side of that equal sign. So in my equation, I would have 1.9 squared, and then is equal to this time. Instead of x squared is equal to. Now my other two sides are what goes next, right? So I would have, again, doesn't matter the order, 1.3 squared plus 2.1 squared. Subtract 2 times those two numbers again. So 1.3 times 2.1. And then we have the cosine of our angle that we started with, which is x. Questions on how I'm setting this up? Okay. So from here, I do want to square my numbers. So 1.9 squared is 3.61. 1.3 squared is 1.69. And 2.1 squared is 4.41. Okay, then again, just like before, I can multiply these three terms together. So 2 times 1.3 times 2.1 is 5.46. And that's multiplied by cosine of x. Okay, next I can add 1.69 and 4.41. So we have 3.61 is equal to 6.1 minus 5.46 cosine of x. Again, do not subtract these two numbers. Do not subtract those two numbers. That 5.46 is attached to cosine of x. Okay, those are multiplied together, so you cannot subtract it. So I want cosine of x by itself. Okay, so I want cosine of x by itself. So I'm going to subtract 6.1 from both sides of that equation. To get negative 2.49. And then I still have this negative 5.46 and cosine of x. Now, since these are multiplied together, I need to divide out the negative 5.46 from both sides. Now, what happens when I have a negative divided by a negative? It creates a positive, right? And I'm going to leave this as a fraction here. I'm not actually going to enter it into the calculator. Okay, I'm going to leave this as a fraction. You can enter it into your calculator, but then your answer might be rounded differently than mine. So right now what I have is 2.49 over 5.46, and that's equal to cosine of x. How do I get an angle measure? What do I do? If I have cosine of x, what do I do to both sides of my equation to get x by itself? You do the inverse. Okay, so I need to bring in cosine inverse to both sides. Okay, because on the right-hand side then, they will cancel each other out, and I'll be left with just x. Okay, so I have cosine inverse of 2.49 over 5.46, and that'll equal x. And that is what you want to enter into your calculator then. Okay, so cosine inverse of that fraction. Yeah, because I can, if I divide a negative by a negative, it's just a positive. It is 62.9 degrees. Questions? Questions? How I set it up, how I solved, anything like that. No. All right, do number 3. Number 3, it's just like the one we just did. Similar to the one we just did. All right, so going over example 3, this is how you should have it set up. If you flipped 3 and 6, that's fine. So if you have is equal to 6 squared plus 3 squared minus 2 times 6 times 3 instead, that's okay. You can switch those two numbers around. So from here I would square each number. So I have 64 is equal to 9 plus 36. Multiply all three together. That's minus 36. Cosine of x. Okay, so I'd add right here. So I have 64 is equal to 45 minus 36 cosine of x. Do not subtract that 36. That is not 0. You cannot subtract those two numbers. Okay? Just because you see 36 minus 36, do not subtract there. This 36 is connected to cosine of x. It's multiplied. From here, I would subtract 45 from both sides. So I have 19 is equal to negative 36 cosine of x. Okay, then I can divide out negative 36. Okay, so I have negative 19 over 36 equal to the cosine of x. And then, again, to get an angle by itself, we have to bring in the inverse. So I would bring in cosine inverse to both sides of my equation to cancel out the cosine on the right. So I have cosine inverse of negative 19 over 36 equal to x. Okay, so I should have x is equal to 121.9 degrees. Okay, so this fraction here can be negative. Don't just get rid of the negative just because you want to. Okay, so it is negative. Questions? All right, one more example here. So this is like the first one that we did. If you already did it, that's great. So first I would locate my angle and find its opposite side. Okay, that opposite side goes on the left-hand side of your equal sign. So we would have x squared is equal to your other two sides squared and added together. Then subtracting 2 times those other two sides, multiplied by the cosine of 125, because that's the angle that I was using. Okay, do you have questions on how I'm setting up the problems using that formula? How I'm getting those numbers? Okay, so honestly, if you just want to take the square root of both sides right away, you can. So if I take the square root of both sides, I could just enter this whole thing. So the square root of 15 squared plus 19 squared minus 2 times 15 times 19 cosine of 125. Yes. Yeah. If you have x on this side, yes. Yep. So you can just type the whole thing in, okay? So you can try that if you want to. You should get 30.2. So be careful.
Got like half of that.
Be careful with parentheses when you do the square root right away. Okay, so you do have to be careful with your parentheses and what you're squaring and what you're multiplying. Okay, if you don't like that and you want to simplify first and then take the square root, you can do that too, just like we did in the first example. Questions? All right, last question I want you to discuss in your groups here. So what methods can you use to solve a triangle? What are the different methods you can use to solve a triangle?
For like the 30, 60, 90 ones, you have to use the like.
I'm just sounding it out. I have no idea. Right, only.
Or I guess you could use, the law of cosine.
For angles, SOHCAHTOA, well, is that only right angles? No, you just have to know.
Yeah, yeah.
All right. So I know some of you are still writing. That's okay. When you ever see a problem like this, and I write the math writing criteria at the bottom, that means you need to write incomplete sentences. Okay? So you should be writing out sentences to answer this question. Okay? It is a writing problem. So if you see that on a quiz or test, know that you need to write incomplete sentences for those problems. So what were some of the methods that you came up with? What were some of the methods? I heard good ones to solve a triangle. Law of sine and law of cosine, right? So those are to solve what type of triangle? Any triangle. Okay, so to solve any triangle, okay, you can use the law of sines and cosines. Okay. What about a right triangle? What can you use to solve a right triangle? Pythagorean theorem. Okay.
Special right triangle ratios. Those things.
So when solving a right triangle, you can use the Pythagorean theorem. Don't spell Pythagorean wrong. It is on that orange poster over there in bold letters. If you can see it.
No, I can't see that.
Okay, so you can use Pythagorean theorem. I heard special right triangles. What else? What else can I use to solve a right triangle? SOHCAHTOA. That's called a trig ratio. To find sides and angles. If you did write SOHCAHTOA, I wouldn't mark it wrong, but they are trig ratios.
Are Pythagorean theorem and then the special right triangles the only ones that only work, or did we learn any other ones that don't do that? I feel like we learned other ones. But
No, we did Pythagorean theorem, special right triangles, and then our trig ratios, and we did inverse trig ratios, so that would be included in there too.